Okay, so let's have a class, and everybody should have a plates of the spread plating. So we want to talk about the results first. So results of spread plating. It is very simple, it's not difficult at all. So you should have 3 plates. The first plate is 10 to the 3 dilution factor. Second plate is 10 to the 5. Third plate is 10 to the 7. Ideally, they should always equalize. Okay, so let's see it. You 10 to the 3 plates should have lots of bacteria there. It is usually uncountable. So we say T N T C. Okay, that equals 2 numerable to count, which means it's too much. You 10 to the 5 should be still uncountable. Or maybe, if it's countable, maybe you did a wrong dilution. Okay, still should be TNTC. Now this plate is countable, 10 to the 7. Lots of you have red colony there, and plus a colorless colony. What this means? Which means the place is contaminated with 2 bacteria, Serratia and E. coli. And E. coli. Because this is a red at 25 degrees Celsius. And we put in the 25 degrees Celsius for 3 days. Okay? I want somebody to tell me what is your number of 10 to the 7. Did you count?
How many colonies?
Yes.
84.
Okay, you get 84. That's good. Who else? Who else has? How many you have, Clayton?
Somewhere around 200.
No, you need to tell me exact number, not around. This is not a guess. How many? Who else? Can you just count how you count it? Like you count apple. 1, 2, 3, 4, 5, 6, 7, like that. If it's really too much, you can split them onto a quarter. Okay? At least tell me the number. What's the number? Anybody have a number? I need one more number. Yes?
I have like 33.
Okay, 33, that's good. Okay, let's talk about that, okay? Let's say I have a 2 plate. Plate 1 and plate 2. First of all, are those 2 numbers we can use? Yes, because they are in the zone of 30 to 300. This zone, we call it acceptable zone. Okay, so now what is going to be the number looks like? This number is basically, because we talk about the 10 to the 7, is the final dilution factor of plates. So that makes your life very easy. How many bacteria there? Plate 1 is 84 multiplied by 10 to the 7. Plate 2 is 33 multiplied by 10 to the 7. So we could get an average. What is the average number? You add up them, you divide it by 2. Is that right? You divide it by 2. Okay? So I'll do add up them, divide it by 2. How many? 117 multiplied by 10 to the 7 divided by 2. That equals 58.5 multiplied by 10 to the 7. Okay. Can you do this? 5, 10, 7, 8, 16, 10, 10.5. You can do that, is that right? Okay, you can do that. You can use calculator, okay? So that's is a number. Now here's something we want to say. In the microbiology area, this number need to change to log 10. Okay, by the way, this is CFU per ml. This is per ml, this is not the whole tube, okay? If the whole tube, you have to multiply by 10. That's CFU per ml. It's a concentration. This is a concentration. The concentration always is CFU per ml, colony forming unit per ml. So I'm going to write again, colony forming, this U is unit per ml. Okay, we need to transfer to log 10 CFU per ml. What is that? Okay, that comes up with how many 10x equals 10 to the 7. Okay, can you do that? How many is this 10y multiplied by 10 to the 7? How many of that one? What is the y? That means how many is 10 to the y equals this guy? So how to do it? 10 to the 1 equals 10, is that right? 10 to the 2 equals what? 100. Is that right? So that y will be between somewhere 1 and 2. So what is that number? You can use calculator. I did about maybe 1.6ish. You use calculator, I'll tell you it's the same. So what is that x? This is y is 1.6, so this x equals 8.6. So how many bacteria it is? This is total approximately 8.6 log 10 CFU per ml. And I tell you one thing, these two students get the number is correct. This is around that range. When the bacteria grow in these bloods at 35 degrees Celsius, 24 hours, you almost get 8 to 9 log 10 CFU per ml. That is a normal number. You get 8.6 average, it's normal. Now you have your own individual number, will be a little bit different, but it's the same thing. So here is the question. Why we want to make it too complicated? Is that right? There is some debate in my area, in the food and microbiology area. Some people doesn't like the log because we have a zero tolerance policy. Let's say ground beef E. coli 0157H7, we don't want any single colony there. So you can use a log, but why here we have to use log? This is the statistics, little bit. Okay, let's say I have a group 1. I have another group 2. Okay, this group is no treatment. This group I have antimicrobial treatment, let's say. This is we did a lot in the lab. Okay, let me show you, we get some number. Group 1 we get 10 to the 5, 10 to the 7, 10 to the 9, 10 to the 4, 10 to the 8. For example, we have 1, 2, 3, 4, 5 number. Group 2, what we get? We get 10 to the 1, 2, 10 to the 2, 10 to the 3, and 10 to the 4. Okay, now I want to compare the statistics difference between these two groups. Okay, I want to do statistics. Statistic difference. What is that? Can we just compare these two group number? No, we cannot just do it. We have to do the first test is normal distribution, is that right? We have to use testing to see whether it is normal distributed. If these type of the number, it's it's obviously there is not normal distributed. So normal distribution, you know that looks like somehow like this. Is that right? In the middle is going to be a peak. You can't compare just these two numbers because there's not for normal distributed. Then what you have to do? All become log 10. So this will end up with 5, 7, 9, 4, and 8. This will be 1, this will be 0.3, this will be 2, this is 3, this is 4. So instead of you are comparing these giant numbers, you are comparing is this group and that group. Now, obviously, these groups follow normal distribution, which means you control the statistics error. This control. Okay, so that's why we have to change to log 10. Now, you can use a calculator. I'm doing too much in my life, last 15 years, so I know how much approximately how much. You can just use a calculator to calculate. Okay, so that's a story. You have to change to the log. Okay, so today's work is so simple. First of all, in your notebook, count the 10 to the 7, how many columns is there? Then multiply by 10 to the 7. You and your bench partner could do is an average. Divided by 2 is the average number. Then use calculator change to log 10 CFU per ml. The reason to do this is that if it is a statistics analysis, these need to follow normal distribution. And when you transfer to log 10, they can be follow normal distribution. Otherwise, you can't do the statistics analysis. The reason is error is too large. Anyway, there is no difference. Okay? So that's something we want to talk. Okay, today's work is very simple. Because you did the spread plating, so the work is not difficult. We will to do pore plating. So I will just write the procedure how you're going to do. Everybody is doing it individually. First of all, you will get this E. coli broth. I hope it is E. coli. Okay, not Serratia. But we'll see. We grow 35 degrees Celsius 24 hours. You will get 3 dilution tubes. Same thing like before. Okay? That is 3 tubes. Each of them 9.9 ml. This is 9 ml dilution tube with 0.1% nutrient broth. I write NB, nutrient broth. Okay, how are we going to do it? I'm going to draw separately right here, okay? This I'm not going to show you again because you know how to do it. Label these tube dilution because we still going to add 0.1 ml from the original tube into the first one. So this will be labeled tube dilution 10 to the 2 because this is 9.9 ml, okay? So this is tube dilution 10 to the 4 and that one is 10 to the 6. Then the first one you mix very well. You will add in 0.1, go to the second one. And then you mix very well. And the last one you go here is 0.1 ml. Same thing like you did for spread plate. Okay, at this stage you stop. You're gonna get 3 empty petri dish. This will be empty petri dish. No agar there. This is the key, no agar. At the bottom of the plates, you're going to label your initial, batch number, bacterial name, and dilution. So the same thing. Batch number, initial, bacterial name, and dilution. Initial, batch number, bacterial name, and dilution factor. Now remember, this dilution factor will be 10 times higher than the tube dilution. The reason is we are adding 0.1 ml onto it. Okay, what's the difference? These empty petri dish, we first of all adding 0.1 ml from tube number 1, 0.1 ml from tube number 2, 0.1 ml from tube number 3. Same thing, only one pipette tips from high to lowest dilution. So this is low, this is high dilution, only one tip. Now what we're gonna do? Since we call it support plating, every place we're gonna go ahead and pour melted agar. Where is the melted agar? Right there in the water bath. It's at 55 degrees Celsius water bath. This will be done by the 2TA. So you do the label, you do the dilution, everything is ready. You said, okay, right, I'm ready to add the melted agar. Then you use pipette to add 0.1, 0.1, 0.1, go this direction. Okay, go high to low concentration. So you add 1, 0, 1, 0, 1. Then we're gonna pour for you. The melted agar is right here. So we're going to just give you one example. This will be very hot, so you have to using gloves. This is melted agar. Like this, very hot. Okay, that's melted agar. And then we're gonna pour for you. And after pour, you're gonna mix it. Very gentle stir. It will become solidified about 3 to 5 minutes. This is like a pudding. Remember, we talked about that. Like you make a pudding at home. It will solidify very soon. But don't flip it over, cause you just made it. That usually need to wait for 24 hours, then you flip it over. We will just let them stay on the top. Put in the incubation, and you can count on Thursday. Okay, so that is gonna be the procedure. This is we'll do it individually. This need to wear gloves. If you're interested, the TA will let you pour a little bit. Okay. But also make sure these agar, you see it's already melted. It's already started to solidify, so some of them. You can see it. So, and then make sure there's no bubble. So I'll be around when you do the first couple of samples. And just as an example. Okay, that's pretty much all I have is count your results. Prepare your dilution, label your tube and empty petri dish. So we'll do the pour plating all together. Okay?